In 1.3, we're going to deal with something called the Triangle Sum Theorem. And the theorem that we're going to be using is where we talk about the sum of the three angles always adding up to 180 degrees. And so I asked you to draw a couple things, two pictures. The first little picture that I have is just a straight line. So if you don't have that, draw one. And I want you to see something, because if you've never been explained the math this way, then this may just blow your mind like it does mine. We'll see. I'm hoping that you're going to see something that you will never forget today, and nothing in a bad way, in a mathematically awesome way. Here's the first thing that I want to show you. I'm going to put a little dot right there, just a dot in the middle of my line, so I know where the middle is-ish. And I'm going to put this thing called a protractor on the line, just so you could see if I was measuring the angle from here all the way around to the other side. I bet you know how many degrees are there. How many degrees is it from this side to this side? So that is a total of 180 degrees. I'm going to just write that real quick right there. You already know that. And I just told you about triangles, that triangles have a total of 180 degrees. So I made a couple of triangles out of scratch pieces of paper. Now you may not be able to see this till I turn the light on, but I labeled the angles. I labeled this angle 1, this angle 2, this angle 3. I made an acute triangle, I made an obtuse triangle, and I made a right triangle out of construction paper. And I didn't measure any of the angles because I wanted you to see how this works. So I'm going to start off with this one triangle right here. And what I'm going to do with it is I am going to move this to where angle 1 is right there at that little dot. I'm going to try to line this up, and I'm going to do the best that I can to put this right there. And I'm going to put a little dot right at the corner, so that if I make a line right there, that should be the same as angle 1. Okay, so let me go like that, hit this, get a little line, and go from here to where I just went. Okay, now let's just look. Is this the same as angle 1 right there? Roughly. I'm trying to be accurate, but is that the same size? Okay, so that's angle 1. Now what I'm going to do is I'm going to rotate this triangle. I'm going to turn this around and take angle 2, and I'm going to line up angle 2 as best I can, lined up just hopefully perfectly right, hopefully there. And let me see if you agree. Does that look like, oh, no, it's not just right yet. How about there? That look lined up to you? I'm going to put a little dot right about there. Move this out of the way. I'm going to click over here, get my line tool again, go from here to there. So we have angle 1, we have angle 2. What do you think about this is angle 3? It's my third angle. What do you think about angle 3? You think it'll fit? Remember how you told me how many degrees this is? Let me click over here so that's not highlighted. Do you think, look at angle 3. Does it fit perfectly? Does angle 1 plus angle 2 plus angle 3, how many degrees does it make? It makes 180 degrees every single time. And as a matter of fact, I went really slow with you with that. And it doesn't matter if it's an acute triangle. It could be a right triangle. I could do the same thing. Let me erase these other two little dots. Whoa. What if I just were to take this one, put it like that? Not very straight. but I'm going to do the best that I can. That's angle 2. Here's angle 3. Still not lined up. There's angle 3. So that must mean that this last angle should fit perfectly, if this is true. And it doesn't matter if it's a right triangle or an acute triangle or an obtuse triangle, it always works, which is kind of an amazing thing about triangles. And what we're going to do today, we're going to deal with a bunch of problems where you're going to have to use the fact that this angle, all three inside angles, add up to 180. So there's my example for you on that one. Now what I want to do is I want to talk to you about the shortcut. The shortcut says this: the sum of two remote interior angles of a triangle is equal to the exterior angle of a triangle. What that means is this. This is considered an exterior angle. I'm just going to label it as exterior right here because I know some of you need a picture. There's the picture. This is an exterior angle because it's outside of the triangle. And we even wrote down a little note to ourselves that says an exterior angle of a triangle is always adjacent to an interior angle of a triangle. So if this is exterior, this one is interior. Exterior angles are adjacent to the interior angles. When it says remote interior angles, the sum of two remote interior angles of a triangle is equal to the exterior angle of a triangle. This exterior angle, the remote, think about when you use a remote at home. Your TV's over there. You use a remote to either turn on your TV or, I don't know, maybe you have a fancy ceiling fan. You have a remote for your ceiling fan. What else do you use your remotes for? Your garage door openers. From some of your parents, you have a garage door that you have a remote. You're far away from it. You press the button, it turns on, whatever it is that you're doing. So what are the remote interior angles? Not the one next to the exterior angle. This one over here, let me put it in blue. This one and this one are the remote interior. That says remote interior. They are the two angles that are not adjacent to the exterior angle. And if you think about it, since these three add up to 180, these three things add up to 180, it doesn't matter what they are. Since this angle is supplementary to that exterior angle, that must mean since these two add to 180 and these three add to 180, if this is the same, then these two and that one have to be the same as well. It's a shortcut. It will save you time when you're dealing with problems. You can still use this fact every single time, but this one will save you a little bit of time. Okay, so I'm going to show you an example of those in just a moment. But first, let me pass out to you worksheet 3. Here is worksheet 3. Save the extras in the back. I will come collect the extras in just a moment. When you get worksheet 3, go ahead and look at number 4. Number 4 says, find the value of each variable. So the first one I'm going to figure out is what is x? And when I look at x, since I know two of these angles inside this triangle, they all three need to add to 180. I can simply go x. Oh, let me switch this back to red. Plus 39 degrees plus 28 degrees should add to 180. I don't really like numbers that are this big without a calculator, so I'm going to do 39 plus 28 on my calculator. That is 67 when I put them together. And then what I'm going to do is I'm going to subtract 67 from 180. 180 minus answer. Oh, I'm sorry, that shouldn't say 180, that should say minus 67. We found our first answer. And believe it or not, I actually found my second answer too. I'm going to use that shortcut. The shortcut, remember how we said the sum of two remote interior angles of a triangle is equal to the exterior angle of a triangle? Let's look at that. This is an exterior angle of these two, and these two are the remote interior angles. Did we already figure out what the sum of those two remote interior angles are? Do you know what y is? If you think you know what y is, tell the person you're sitting next to if you think you know what it is. What is it? If you said 67 degrees, please raise your hand so I can see how many got it right. Well, okay, that's a little over 60%. That's about 60% of my class. Not bad. Not bad. That was a shortcut. If you did not get it, you could always do 180 minus the 13. You just have one extra step, and we've already done that. Just trying to show you a shorter way to get there. Once you get what y is, I usually write it in the picture. And then we only have one last angle. It is not an exterior angle, so we cannot use a shortcut here. But what we can use is the sum of these three angles. Since they're inside a triangle, they should add up to 180 as well. So I'm going to write 64 plus 67 plus z should add up to 180. Still recommend a calculator because 64 and 67, let's see, 120, 131. But I'm going to double check myself. Yep. I want z by itself, so I'm going to do the opposite of adding 131. I'm going to subtract 131 from both sides. One thing I do like about this calculator that I may not have told you before, but whatever my last answer was, if ever I want to save myself some time, if I do 180 minus the last answer of 131, it remembers that. So I use this button down here where it says ANS. That stands for answer. It will take my previous answer of 131. When I did that problem, it will take 180 and subtract the last answer. So I don't have to type it again. One button versus writing 131, pressing three buttons. It saves you a little bit of time. 49 degrees. And we found x, we found y, we found z. So far, so good. I have two more examples for you. These ones will go quicker. Number 10, if you want to do this on number 10, you are welcome to do so. My first question to you, I think all of you should be able to answer this. The angle that I am pointing at right here is how many degrees? Well done. And I almost think it's easier to find x because I use that shortcut all the time. This is an exterior angle. There are two remote interior angles. I bet you could figure out what x is if you know how to add these two numbers in your head. I'm going to even write it down here. X is going to be equal to 90 degrees plus 34 because those are the two remote interior angles. Pretty sure it's 124. Did anybody else get 124?
Yeah.
Good. For angle Y, we can do 180 minus 124. And if you're using that answer button, might save you a little bit of button pressing. Not a lot, just a little. I'm getting y as 56 degrees. One thing I do recommend, as you're writing these things down on your, don't forget to write down how I am doing this, just in case you need a clue. Sometimes writing down the work is more important than writing down the answer. Last example I have for you. The hardest that it gets, in my opinion, on this worksheet is number 11. Number 11 says, find the values of the variables and the measures of the angles. We have this angle and this angle and this angle. And we have a 3x and a 4x minus 1 degrees and a 3x degrees and a 90 degrees. And you're supposed to use the fact that all these three angles add up to 180 degrees. So you need to write an equation that says the 4x minus 1 plus the 3x plus the 90 degrees, all three angles should add up to 180 degrees. It's in parentheses though. Okay, well, it means that that first angle plus the second angle plus the third angle should add up to 180. Since there's nothing in front of the parentheses, they don't matter. You don't have anything to distribute or multiply. We're just going to put the 4x together with the 3x. We're going to add them up to get 7x. We're going to put this negative 1 together with the 90 since they're on the same side. 90 minus 1, I believe, is 89. And now we're right back to what we did in worksheet 0 and worksheet 1. Worksheet 1 and worksheet 2. We subtract 89. We do the opposite. 180 minus 89 is 91. Divide by 7. I don't know if that goes in evenly. Oh, it does go in evenly. 13 times. Whatever you do, do not stop when you get your answer because it says find the value of the variables. Yay, I did. I found x. But it also says this. And as I was looking at your test, I did look at your test the other day just to make sure I'm teaching you what you're going to be tested on. The people who will miss the multiple choice questions will stop right here because this will be a choice. But it might say find the measure of the angles. If it does say that, you need to plug this back in to figure out how many degrees each angle is. So how big is this angle? 3 times 13 is 39 degrees. 4 times 13 minus 1 I'll write that over here. 52. 52 minus 1 is 51 degrees. So we found the measure of the angles, and we have figured out what x is. We're going to stop your notes right there.